And that's essentially what this patch-based modeling is. It's a way of modeling smarter rather than harder. I've got, of course, some details here. There's actually a PDF version, which again is 10 years old, but actually does still follow the process. And you can see here, instead of even using a reference image, we're just going to use a cylinder to represent what the middle of the tire would be. So we have something to model to. And starting with a simple cube, modeling and deforming that cube in such a way so we get half of a section, which then we can duplicate, weld together, extrude, and then when it comes time, basically weld all those together and then use a deformer to bend it in the shape, because it's much harder to model something that is 360 degrees around. If you think about, oh, I can just model it straight and then bend it around. So we'll be getting, of course, to this in a second here. Another example I have here is just some samples, like I said, from students past. Now, in the description of the project, it does say, hey, we're modeling a car tire, and then we'll show you how to model the rim using a primitive tube that we can then smooth to make it all shiny and polished and kind of like really high poly smooth. But this is just an example of what a student in the past basically delivered. It's just one, and then they duplicate it, offset it, put one on the corner, just to make it kind of just interesting in that sense. Another example here of a student, so let me just find one here. See ya. Where are you? For some reason, the X that I am reading on all these is upside down. This isn't one. Imports. Yeah. No, that's right. And once again, you can see some examples of the car tire. And that, you really don't see it here because, again, does she have lights on? No, but it's just been textured with a simple black shader. I'm going to show you how to do a couple different simple shaders here. Maybe we'll do like a white wall, like an old school kind of tire or something like that.
Ooh, I like this.
Don't have to necessarily go with the whole lighting and all that, but again, we'll get there eventually. I'm going to start here, of course. Remember our process, new, always if we're starting new. File, project window, new. This will be, of course, your car tire or something like that. Make sure you are going to put this into your proper assignment project folder. So we just go here to here, modeling, assignments, watch model tire, and I'll select that. So it will make a folder with all the appropriate subfolders, accept, and it has thrown it there into, see, entire project with all the appropriate source imagery or everything else, the scene file, whatever. Always step one. Now, again, if you're going to work on this later on, you would simply just go to File and set project to that project on a different machine. And now it's connected to that project folder. But I want to just start here by just kind of going over some simple premise of what is this whole patch modeling process. Now, obviously last week, right, we learned how to work with a primitive shape, go into it, and then play around with segmentation. And then, we could take a vertex, right, and deform and shape, or we could select by edge and move it, or we could even select by face. Right, and move either the face, or even come up to some of the simple modeling elements here, like, again, extrude. See, and if I hit extrude there, it gives me the ability of extruding that polyface, see, and even scaling and doing all this stuff with it, see, to create and model more geometry. In addition to that, I'm just going to start off with a small polyplane here and simplify it down to about, go with 3, okay? Let me hide my grid. and wireframe unshaded. So here again, right? I can extrude, I can do all this stuff, but I want to show you again what we can do in the name of making patches. So you see, I selected that middle portion there and I hit delete. Now be aware that if I hit 3 on the smooth, see, 3 on the smoother, a 1 by 1 by 1 poly actually is circular when you smooth it. See that? But I don't want to skip there yet. So let me just go back here. But imagine now if we go by edge. I'm going to hold shift and grab those edges here, right? And I'm going to extrude those edges downward. Okay, so you see what I'm doing here is I'm just shaping that into a small little patch. Make sense? Now, what if I were to take that, duplicate, and line up these edges as close as possible? See that? I could then take the two, combine them like we've seen before. The problem is that this edge, this seam where they were so close together, isn't actually welded together. So what I can do is select those vertices, right? And I can merge. Okay, now you see, if I zoom in, you can see it doesn't merge them by default. See how there's still that little gap? Even though they're close together. That means I have to come over here to this threshold. You see how I get the little arrow back and forth? Just slide that over, and what it does is it just snaps them together. Kind of like if you're working in Illustrator and you need to join two vertex or 2 points together. So that now I've got, rather than, oops, I'm just gonna F8. So now, rather than one piece, I have patch modeled these two together. So you can imagine how quickly now you can create lots and lots of geometry. Watch this. Put that over there. Okay. Now, I'm just temporarily going to do this. Duplicate, and I'm going to move this over until I get a number where that lines up. Right about there, and I moved it about negative 17.3 in the Z. Negative 17.3. Remember that. Because watch what I can do. Edit. Duplicate special. Let's make 6 copies. Okay, let's reset this. Let's do 6 copies of this. Moving negative 17.3 in the Z direction. X, Y, Z. Watch what this will do now. See, it now has duplicated multiple copies of that. And now I can do that same kind of combine, vertex. Now remember, wherever those duplicates overlapped, there was a little bit of a gap, but that gap was so small that I could literally select all the vertices here and merge and mess with that threshold until they're all welded together, because there's no other vertices close enough. You see, it only gave me a distance of 1. So that now I have, right, a complex patch worrying about one small detail. And I could keep going with this. We've learned already, hey, what if I were to mirror this, but in a different axis? So let's say Y. So I'm actually going to go in the Y. See that? To mirror. Then I can say, hey, all edge loop. What's this? Shift. All edge loop. Mesh tools. Bridge. Well, maybe I'll do a bridge of 1 just to get a little bit more detail. So you see now I have made this complex block, right, out of just one small detailed section that I then duplicated, welded or merged those vertices. So just using this simple element example here of just, hey, I'm just going to focus on one little patch. So any kind of detail like that can be done. And then you can make a large variety of geometry. Think about a lot of man-made things are built that way, right? That's why we're using this car tire. It's a man-made thing. So it's been industrially designed and fabricated, and they're not making, it's a lot easier to just make a big long strip of this stuff and then cut it and shape it than trying to make it physically the way it appears. Okay. So really, that's what patch modeling, and that's how we can make holes in things. And let me just show you here again, because we are going to start to talk about smoothing. Okay, right now it's a very lightweight polygon object. If I hit 3 on the keyboard, you're going to see, okay, now it's starting to look kind of soft. Because the smooth, what it does when you hit this, no, it's just the visual, not the real smooth. Okay, it's just a visual smooth. Come in here and hit my render key. Just switch this to software a second. You'll notice it's still blocky. And that's because that 3 on the keyboard only represents what would this look like if it was smooth. What that can teach us now even is, let's do this. I'm going to do an edge loop going all the way around the edge. See that? Let's do a bevel. I'm going to move this edge way up towards the top. Double click this one, move it way towards the bottom. And I'm going to select the 4 corners with a double click. Let's try that. I'm just holding shift, double click, and double click. So I've got only the 4 corners. And what I'm going to do with that? Bevel. Let's make it be very small bevel. So what edges or edge qualities or something that if you've ever worked in Adobe Illustrator, again, you know that wherever you put 2 vertices close together, you're going to sharp a corner. Okay. So by doubling up the corners here, 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 if I go now and hit smooth on this, or at least visual smooth, it's going to hold the square shape of the box, but yet round out the center. Let me show you what I'm talking about. Come on, put a request in. So you see now it has smoothed out these that are lightweight, but because we had double edges, it holds those double edges. Be wary though, even though it appears smooth, it's still not smooth. That's because if we want to create a smooth surface, we literally have to go to mesh and smooth. And what the smooth does is it takes every single face and splits it in half, each direction. So 1 by 1 by 1 becomes 4 or 2 by 2 and so on. Because it's division by 1. And now that is an actual smoother that if I were to render it, holds that smoothness. See that? What if I was going to come here and say, hey, do a division here of 3? Now we're talking very high poly, right? And of course, more and more smoothness to it. So this is why we have to learn to model low poly, model lightweight, so that we can then simplify it down and then add the edges to get more smoothness or less. It's kind of like if I were to, and you can see here, even here, I could come here and break down all. No, I didn't mean to do that. I meant to remove it. Poly smooth. Delete that. I don't remember what it was. Remove. Oh, I guess I could just do divisions of 0. So I just removed it in that sense. Right? Because I'm here now. I'll just show you what I'm speaking of here. Edge. Right? Selecting that one edge there. Very quickly come here, bevel that. Very small. And you see now that will double up, which gives me, see how these are much smoother? This is more sharper. So wherever you have edges close to edges, you can get a corner or the closer thing to a corner. So it doesn't just, turn into a smooth ball. Let me just do this quick and show you. So good old fashioned 1 by 1 by 1 cube. Hit 3 on the keyboard, it's actually a low polygon sphere. What if that 1 by 1 by 1 cube, I want it to not be as sharp as this, but look maybe a little smoother like a dice? Well, that can be achieved by literally selecting all the edges and beveling them very, very close together. Like that. So if I hit 3 and smooth it, now you see it is a smooth cube. See that? That is the secret of going from low poly to high poly, or only putting the polygons, the edges, and all that stuff close together wherever you want sharpness. I did that. Just to show you again. Let's do another bevel. Let's make it close, but this time segments, I'm going to put 3. And so now you see, without even needing to push 3 on the smooth key, see? 1 versus smooth visual 3, they pretty much look identical because I put the edges where I need to put the edges. And so that's what we're dealing with when it comes to going from a low poly geometry to wanting to see what it looks like smooth, but yet not having to see it smooth. Meaning we don't need to go smooth. All right. Just a little bit there. And like I say, I'm kind of breaking down a little bit I have here in terms of faces, vertices, and edges now, how to put a hole into something or creating an opening, attaching geometry and welding using vertices or edges or something like that. Talking about copying and cloning, which is what I just said about duplicate or duplicate special, or what I did duplicate with transform with the seat boards last week. And I'll talk about here, of course, is the deformers as well. So here's that PDF that kind of walks through this tutorial of the tire.